Okay, and we're COMP100, and it's lesson 5, week 5, part 2. Okay, and we just kind of talked about substrings and strings, and I did a bit of a review from last week just to help you guys with what's going on for your assignment number 1. What about constants? If I want to make a constant, what would you think? We made a variable, okay? A variable is a location in memory, right? But the value can always change, right? So it's something that I'm going to use as a value. Here's an example of that. So here I'm going to go back to my drawing board here. Let's go back to the drawing board. Follow me here, guys, for a second. I know you're busy trying to do your assignment, but you got some time to do that until Friday. So I'm going to kind of put it together this new. Here's my board, right? My blackboard, my whiteboard, if you will. And what I want to do here is I want to talk about a couple more memory locations. So here's a memory location. Let's try that again. Here's a memory location, right? And this one is a variable, right? Okay, here's a variable. And this variable, what does a variable mean? Right? What's the difference between a variable and the memory location itself? Does anyone know? So if I say the variable name, what's the variable? And the variable is the name, and this is the memory location. So the variable is actually a friendly name for the memory location, which is a number or something, 1, 2, 3, 4, 5, whatever it is, right? Well, the variable actually can change. So if I assign something to the variable, like prompt, I've been using prompt all the time. I assign prompt to the console, and then I change prompt again. I keep on prompting things, and everything that I put into the console goes into prompt. So the value of prompt keeps changing. But what if you want to have a variable or a memory location that stays always the same and can never change, right? Well, we have something, a construct like that in programming languages, and we call that a constant. Right? This you'll be tested on. Just letting you know. So there's a variable and there's a constant. A variable, right? Some of the things you have to know about it is, well, it can change, right? That's one of the things you can know. Here, let's undo that. So a variable can change. Okay, variable can change. Constant, you know, when we talk about a constant, it can't change. It can never change. It's always fixed. Why would I want to have constants in my code? Why don't I always use variables? How come? Anybody have an idea? I'm going to start picking on you guys now. Come on. Why would I care about? Why would I only make it so that? That's interesting. If I just flashed out of the screen here for a second. Let's try that again. All right. Hopefully it's going to record that. Why would I have constants at all? Why don't I just have variables for everything?
Well, constant is more accurate, as you say. But you got more precision.
It's not a precision thing. Constants means it's a memory location. I can store a value that will never change. Never change, ever. When I put a value in a constant, it'll always be the same. That's why it's called a constant. It's constantly the same value, whatever I put in there. And it can be of any data type, right? It can be of type char, of type string, of type int, of type float, right? It's always the same data type. Why would I want that? Well, imagine if I want a calculation, but the number that I'm calculating against, a factor, if you will, is always going to be the same. I'm always calculating the same value and over and over again, right? This is where I would have a constant. I would use a constant. Example, if I'm making a game and I want to keep track of the number of lives of a player, right? I can say lives. Let's try that. So here I'm making a constant. I'm going to use the keyword const, right? Take a look. This is how you do it. Const. And then I just declare what type of constant it is. I have to declare the data type now. So it's another little modifier. It's not just the data type you need, but const. And I put in there int, right? Now typically the naming convention for constants is we use all caps with underscores, like this. Player lives, right? And we assign it right away, right? Const player lives equals to 3. 3 lives. And we play in most games, right? You live 3 times and then you're done, right? Okay. Constant. Why would I want to do that? Well, if I want to calculate something, if I want to know how many player lives I have, that's a way to do it. Here's something else. You're going to do a calculation in your code, the radius of a circle, right? Well, you have an float. Here's a floating point number, right? And you want to call this pi, right? And pi is equal to 3.14, right? F, right? Here's 3.14 F, right? That's a const, right? And it's going to always be the same. So then I can always do my calculations. It's never going to change. I'm never going to change the value of pi, but I don't want to use 3.14 because the number may not mean anything to me, 3.14. But I know what pi is, right? So I might want to do something like this. I may want to declare a float, right? That's called radius for the circle, right? And I want to say, well, guess what? If I enter radius, I get a prompt for radius. I get a console I can convert, right? I can't convert to float, right? But I can convert to double, right? I can convert to decimal. Those things I can do, but I can't convert to float. So if I'm smart, I'm not going to use float here. I'm going to keep everything double, right? Change this F to D, or right? Change my float to double. That's the way to go for radius, because I can convert to double, right? And from double, I can say, you know, I can do it one line, console.readline, right? Right in here. And I can put this inside my conversion. So I don't even need a middle variable like prompt. I can take the output from console.readline and put it as an input to convert my double. Right? That's a quick way to do it without the use of prompt. And then I can take this value that I'm going to get and plop it into radius. That's the radius. And then I can take my radius, right, and I can multiply it by radius itself, right, and then multiply it again by pi. The right way to do it would be do something like this. Radius times equals to pi, right? So that means that radius is equal to radius times pi. That's one thing. And then I can multiply this result by radius again, right? Or I can just write it out the long way. If you don't understand this notation, I can say radius is equal to radius times pi, which is the long way to do it. And if you notice, pi is 3.14. Always going to be 3.14 for now and for forever. It's a constant.
I was trying to do that number 3. This math, and then dot.
You could use that, right? But that's a different thing. That'll give you different precision. This will only give you 3.14. If you go do the other way, right? I could do that too. Instead of pi, right? I could do something like this. Up here I could say math.pi, right? So instead of always going math.pi, I can make it a friendly name for pi called pi, right? And I could do this. See? Many, many ways to do stuff in programming. It's like art in many ways. It's like literally writing a story, right? So we're doing conversions. That's what we're talking about, right? That's the first thing. And I'm talking about constants. Constants, right? And constants is a value, usually in caps. This is our convention. We always put it in all caps. That's the convention for the identifier, right? The name of the constant, right, is always in full caps, all caps. And we assign it pretty much as soon as we get it. That's the way we do it. And then we use it over and over again.
Isn't math.pi a
math.py is I'm using it is a constant. I'm just assigning one constant to another, right? But math.py is very much more accurate than pi 3.14, right? It's way more accurate. If I print out math.py, it's like 3.14159286739, whatever it's going to be. It's really long, right? So you got to be careful. If you do this, it's not what I asked for. I asked for 3.14, and if you use the other one, math.py, it's more accurate, but you're going to have to chop some numbers off, do some other calculations. Okay, so going back to this. So again, a variable can change, just as a review. A constant, always the same, can never change. And you use it for special circumstances. Like for example, if you want the maximum value of something. If you say, I want a number between 1 and 10. Well, my maximum is going to be 10. So I would set up a const. Let's just get rid of this example. And set up a constant. I want to call it max, integer, max, right? And I assign it 10. So I've got a constant with a maximum value of 10. And you can make a notation, some kind of comment like this, represents the maximum value. This is your own stuff that you're doing, right? Maximum 10. And you're always going to be able to do something with a maximum of 10. If you can make this double float string, like, for example, I always want to say hello world in the same way. I can make it string, right? I call it hello. This is weird, right? And I can say, well, it's equal to hello world. Hello world is always with an exclamation mark, right? So if I want to say hello now, right, I can just use this. And I know what it means, capitals. It's never going to change. It's always going to be hello world. I can never change the string. I can't assign something to it. It'll give me an error. Here's an example of that. Now if I say hello, right, is equal to goodbye, or, goodbye, right? I can't do that because it's a constant. If I do this, it gives me an underline that says the left-hand side of an assignment must be a variable, property, or indexer. Right now, the left-hand side of my assignment is a constant, and it'll give me an error. It won't allow me to assign something here. It'll only be used for output, not for input. Okay, so that's what a constant is. Be aware, because we're going to use some constants in our code. Okay, so constant, a variable can change, a constant cannot. Okay, here's something that we should always talk about. I want to create some identifiers, right? And they're called, this is a very kind of an advanced thing that you should know how to do. They're called enumerations. Enumerations. I can specify a bunch of these enumerations. There are a bunch of constants, and they're represented by identifier names, and they have a value at the end, a value, but we don't care what the value is. We just want to know, when I say Sunday, I mean Sunday. When I mean Monday, I mean Monday, right? So an example of that is Sunday would be 0, right, in this enumeration. Because remember, we're talking about zero-based counting. So this automatically we have a value of 0, 1, 2, 3, 4, 5, 6, right? Why? It's like a big array or string, if you will, right? But now what I can say is day of week, right? And I can say Sunday. Let me give you an example of that. So when I access the day of the week, right? When I make an enumeration, here's what I can do. Let's call it an enum, right? Enum. And my enum is going to be called, I'll do the same example, day of week, right? Here's day of week. Now day of week, right, if you notice what it says it expects a semicolon, right? Well, I don't need to do that. I can go day of week is equal to Monday, or sorry, well, start Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? And if you notice, it says, hey, I've made an enumeration, right? And instead of actually, I don't need to use the equals, because basically what I'm saying is my enumeration, right, is this: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? Here it is. Okay, cool, cool. Now I want to access my enumeration. How do I access my days of the week? I got to say something like this: day of the week, right? And I want to access my members. How do I access Sunday, Monday, Tuesday, Wednesday, and so on? How do I do that? Because once I call enum, right, it's a bunch of constants, right, that make up the day of the week, right? So when I say in the day of the week enumeration, Sunday is 0, Monday is 1, and so on, right? So how do I use, and here's an example, by the way, of a constant. Constant tax rate is 0.06%, right? My tax rate's never going to change. So it's a good example of a constant, which is double, by the way. You know, it's always double, 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 because you can't convert it to float. And here's all the, by the way, here's all the conversion classes that are here captured. So you can go to Boolean, to byte, to char, all that kind of stuff. Let's go back and try this enum though. And let's say, for example, you know, you don't have the book and you don't understand how this enum works. We mention enum, right, which is here, enumerations, but we don't mention how to use them, right? All it says is, let's use the enumeration. And it says, by default, enumeration values are integers, and the identifiers in enumeration are often meant to hold consecutive values, right? But it doesn't tell us how to access our new enumerations. Let's go back and try and do that. So here we got day of the week, right? But I can't do something like, can I do something like Sunday? Can't access Sunday. How about day of the week, right? How do I, it's not this way. I can't go Sunday, right? Can I? How about the colon? Can I use colon? There's got to be some way I can access day of the week. The other thing is when I put day of the week up, it's like it had day of the week. That was another thing that we had a problem with. Let's call this day. Enum day, right? And if I go day, but day is also a reserved word. Let's try something else. My day, right? So my day, right? And I want to kind of put, I can't index it somehow. I can do this, right? But that doesn't really mean anything, right? And I can do this. My dot accessor method doesn't work, right? So how do I create an enum, right? Well, maybe I don't know how. Here's a perfect example of doing it with Google. Let's Google it. So enum in C#, right? All right, how do I do the enum C# reference? I got to look and see what it looks like. So here goes enum days, Saturday, Sunday, Monday, Tuesday, Wednesday. Here's a great example of that. Same kind of thing we saw before. Make this bigger for you guys to see it. There we go. Here's enum days. This is right from the Microsoft site. And this is what I want you guys to do. Right? I want you guys to look at the help, okay? This is interesting. So I say every enumeration type has an underlying type, right? Which can be an integral type except char, right? So enum days, right? And then I assign it a value, right? And I can actually start to count at a certain level, right? So 1, Saturday we start off at 1, 2, 3, 4, 5, 6, 7, Saturday to Friday. I can do that. How do I access an enum? So here I select days, Sunday, Monday, Tuesday, Wednesday, Thursday, so on. And I have to access it here, right, by casting it days.sun, days.mon, and so on. Well, that's what I try to do, but not working. How come? Right? How come? How come it's not working? Let's do another little example. Enum range, right? Range is equal to a long. I've got a maximum value, right, and a minimum value. So 2 items in my enumeration, and they're of type long. Okay? When I access them, I go range.max and range.min, and I cast them as long. Right? This method here is another way of converting something. We call it casting. Okay? Let's do it one more time. car options. Okay, here's my car options. Spoiler, right? 0x01. That's in this particular case, it's just flags. Sunroof, fog lights, tinted windows, right? These are just flags. And here's my flags test, right? And I can use this pipe character to do this. So this is all good. This is what I thought it would be like. But you know what? When I tried using my enum, right? My enum, it doesn't work.
You know what I noticed?
Tell me.
Is they put the code before the static void.
Very good. Very good. I'm glad that you noticed that because this I wanted to show you over and over again. So if I did that and I put it before the public static void main up here, let's take this enum, right? I take this out and put it up here and I say my day, right? Hey, I don't get an error. Now can I use day in here? So my day dot, oh, there we are. Friday, Monday, Saturday, Sunday.
So it becomes like a library kind of thing?
Correct. It becomes almost like a set of constants that's available to in my entire code base that's inside my program, right? And I could simply do the same thing. If I wanted to have a constant up here, right? And if I call this constant tax rate integer, tax rate, right? And let's say my tax rate in Canada for my HST, actually it should be HST, call it HST, right? Right? What's the HST?
13%.
How much?
13.
13, man.
16?
Let's say it's 15, right?
Isn't it 13? That's
No, it's 13, but let's say it's 15, right? I can't be an int because int and 15% or 13% doesn't work. So I want to probably make it a double, right? And I want to make it, instead of 15, I'll make it 13 to be more realistic. And I can use the D. Now, if you notice, it's outside of my class, right? And automatically, as a constant, if I use HST in here, right, now it appears here as a little bit different. Take a look. Right? There's a little symbol here that's a little bit different than what it was before. It actually looks like my enum. So here's my enum, and I go my day, right, dot Friday. Look at the symbol here, right? It shows up differently than a variable, right? And all I'm doing is I'm setting it up. Now I can set it up so that Sunday, right? Sunday is equal to 1, right? Sunday is equal to 1. I can do that, right? Because it defaults to integer, right? So instead of counting with 0, I can start counting at 1. And if I want to print console.writeLine, my day dot Sunday, or I want to call it, you know what? I don't like my day. I want to call it day of the week, like we did before, right? So I'm going to refactor. I'm going to double click here, right click here, go to refactor in my context menu, rename, right? And I'm going to call this day of week, right? And I apply it. Now, guess what? This changes down here too. But you know what? I don't want to use day of week. Let's refactor it again. Let's try it again. Refactor, rename, weekday, right? Weekday, which makes more sense. Weekday, Sunday, right? So I want to say, I want to kind of write line Sunday. And you know, whenever we do a write line, I want to always do press any key to exit. And I want to do a console .read key, right? Well, let's format that over here like this. Okay, let's save it and run it. And when I run out, it says, guess what? It says Sunday. Did it give me the value of Sunday? Nope. Because it's a constant, it's a placeholder, and I can test for that. So that's what I want to show you. It gives me Sunday as the value. If I skip over this, it says Sunday. It starts counting at 1, just in case I want to compare it, but it'll never be 1. If I want it to be an integer, I could cast it as an int, right? I could say it's an int 32 or an int, right? I could do that. And then if I want to print this out as an integer, I'd have to cast it by going int, right? Weekday, Sunday. And then when I did that, when I start debugging one day, it'll say 1, right? So when we convert stuff, there's a couple ways we can convert things. I could convert using the convert.toInt32, or the other way to do it is, if I want to do a read line, console.readline, right? I'm entering some data in here, right? And you know what? I want to do a console.write. Enter your age, right? And when I read line in, I'm going to assign it to age, which I'm going to kind of declare up here. Say int age, right? And I'm going to say age is equal to console.readline. It's going to be an error because console.readline is what? A string, right? Well, I can always try and cast it, is what it's called, by using this notation. I can try and cast it to an integer, and it'll give me an error unless I cast it to int32, right? Which will still give me an error, right? Because I can't cast int32. There is no int32. But I could do one of these. I could say convert dot to int32. Here it is. And then put that inside here. My console.readline in one kind of fell swoop with no prompt. Because the prompt is just a placeholder. Here's my console.readline. It's going to return a value. The value is going to be whatever I enter. Then I'm going to convert it and put it into age. Right? Just like I did last time. So weekdays is a good way of keeping track of a value, which we don't care about the number. We just want to say, you know, if it's Sunday, you know, day of the week, or if it's player lives, or I want to have other constants that I want to use. Let's say I want to have a bunch of constants in an enum, right? I can set them up, right? And it's almost like a way of keeping track of some basic items that'll never change. There's always going to be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and the days of the week. Always, right? And what we need to do is we need to convert them into integer or whatever we're going to convert them. So for example, if I want to take my day of the week, Sunday, I want to say age, I don't know, or maybe I'll say day. Here, I'll make another integer. So I'll call it day, and it's integer, right? And I'm going to say day is equal to Sunday. Day is equal to weekday, right? Dot Sunday, or Sunday, here we go. If I do this, right? And I want to print the value of day out, it's going to say, hold on, day, an explicit conversion exists. Are you missing a cast? I want to convert it to integer thing. I can always use the convert dot toInt32, where I cast it. I convert this weekday into a number, right? Because the weekday, even though I've made it a number, right, it doesn't see it as that. It's an enumeration. It's different. It's another data structure. So I've shown it to you, but I'm putting my hand up right now and telling you I'm not going to test you on it right now, right? You've seen what an enum looks like, but we're not going to use an enum because it's an advanced concept, right? Just like other advanced concepts, I'm going to show them to you, and we're going to move on. Too much for you guys. Okay, but we know what constants are. Constants, this kind of goes in line with constants. Constants are values. We set up a friendly name for a memory location that never changes. Okay. let us go to the next piece that I want to talk about. So we've done a bunch of stuff with data, and now we're moving into decisions, right? And I've got assignment number 2, right, which I'm going to talk about in a second. But let's talk about decision making and how we make decisions in C#. Okay. Again, I'm trying to catch you guys up because you guys missed like 2 classes before we got together, right? So you guys are behind. So what we're going to talk about is we're going to make decisions with the if statement. Talked about kind of if statement briefly last week. I kind of brought it into play, but we never really talked about what it does, right? Okay. Again, let's think about a couple of things. Sometimes we're going to use pseudocode, right? Pseudocode is kind of a programmer's way of putting together, you know, a decision, like almost like writing some basic English to discuss how we're going to, how our program is going to flow, right? Yeah, chapter 3 we're not doing. Chapter 3 is only for GUI, right? We're going to come back to it in programming 2. Right? We're not going to touch chapter 3. We're going to move to chapter 4. Okay? So pseudocode is, we're going to use pseudocode for, to talk, kind of write plain English and kind of describe our logic, right? And then we're also going to talk about flowcharts and a sequence structure. Let's take a look at what these things look like. Here's an example of some pseudocode, right? Here's what we want our algorithm to do, our little piece of code. Go west on Algonquin Road, turn left on Roselle Road, enter expressway heading east, exit south of Arlington Heights Road, proceed to 688 Arlington Heights Road. Okay, these are all the things we want our program to do, right? Well, here's the first step. Each step is got its own little piece. Go west, turn left, enter expressway, exit south, and proceed. Right? These are all little pieces of code to tell the computer to do something. These are all in line. So take a look at this. When we write this, we're writing little boxes that tells us what to do, almost like a little procedure, step by step, that's telling us what to do. You're going to see this in code. So someone asks you, hey, when I'm going to use a flowchart to describe my program, this is how you would start. All right. When we come into a decision structure, right, what we're talking about these yes or no or true and false decisions. This is what our decision tree would look like with true and falses. All right. So when we go straight, we use the square boxes, right? And when we have a decision to come up, we use this triangle, okay, or this diamond shape. Sorry. The diamond shape tells us true or false. It kind of leads us into different directions, okay? So if I'm going to draw it out, let's draw out some pieces, some decision. All right, so I'm going to go back here, right? And I'm going to make a new kind of new code here. And in here, I got my first piece. I say, you know what? We're going to start programming, and the first thing I'm going to do in this box here, right? I'm just going to make kind of a smaller font. I'm going to go with a 12, right? Maybe that's too small. Okay, there we go. So the first piece we're going to go is, let's suppose you're defining your journey into the game. So the first thing is you're going to go into the cave. Go into a cave. Okay? Take a look. So this is my first piece of my decision. I'm going to go into my cave. We're going to use a square or a rectangle for that, right? And the next thing, after we go into our cave, right, we're going to draw a line. So if I'm going to make you draw a structure, some pseudocode, which by the way, I probably will make you draw some stuff out, it's going to look like this, right? So I've got my my first thing, my first piece of code. It's going to tell us to go into a cave, right? And when I get to the cave, I'm going to have a decision to make, right? I can go left or right, right? Do you want to continue? Maybe might be the decision node. do you want to continue? I'm going to draw a diamond shape. There we go. One day we get it. And now, of course, you can go either this way, right, in the decision structure, or this way. You got two ways you can split off. And of course, if we're going to name it in terms of the way it's going to be named, it can be true. I want to continue, right? Or false. I don't want to continue. Right? So here's false. If I say true, right, that I do want to continue, right, I'm going to get to another piece of my kind of code that gives us other directions, right? So the question here is, I go into a cave, and my question first becomes, when I go into my cave, do you continue? This is a dark cave, let's say. And my do you continue statement happens in here. Right? Do you continue, true or false? If I do, I go this way. If I don't, I go this way. If it's false, I don't continue. I leave the cave. What happens? I'm done. Right? So we're going to make a little end piece to this whole thing. And you're going to see sometimes the decision structure shows a circle, right, for an ending, if I can actually draw it in the right place. Right? End. That's what this little circle means, right? If it's true, you want to continue, right? Then what we may have to do is make some more boxes. So there's a box that continues. You want to continue? Fine, right? You continue. That's what happens, right? So here, continue into cave, right? This is what happens. This is our decision. And then when we get into the cave, right, I'm going to make another line, right, that's going to give us some more action, right? So for example, I'm going to go into the cave. I'm making my decision matrix here, and into the cave, I have another decision point to make, as an example. And let's say here, when I'm in the cave itself, I find my way out. It's a very simple decision structure. Or find the treasure in the cave, right? If false, I leave. If true, I continue into the cave and then find the treasure. Very simple decision structure. And I use the diamond shape to denote true and false. Okay? So again, if I go back to my PowerPoint presentation, it's kind of the similar thing. I go west on Algonquin Road. I turn left on Roselle Road. Hey, is the expressway backed up? True? Well, you know what? I'm going to take a different route. Yeah, if it's false, no, I'm going to go on the expressway and get here. And both routes lead to 688 Arlington Road Heights. That's home, right? But I decided to take this way because the expressway was blocked, right? Another way I would say is, how do you guys get home? Do you take the bus, Lennon? Okay, so take the bus. So what about the buses? The buses, the first bus that comes, right, as an example, it's full. What do? You wait for the next one. So this is the decision tree I'm going to make now. Wait for the bus. If bus is full, keep waiting. Okay, I waited again. Is it full? Is it still full? Keep waiting. Is it still full? Keep waiting. If it's full, keep waiting. See what I'm saying? The if statement? If it's no buses, but what if you wait more than 30 minutes? I can keep track of the time. If you wait more than 30 minutes, you walk to the next bus stop. That's a decision you made, right? You not walk down to the next bus stop for whatever reason, because you're tired of waiting because you're cold, right? Decision after decision, right? Simple as stupid example, but okay. Think about a pathway that you're going to take a path, right? And you don't know which way is right. You don't know where the treasure is. You're going into a labyrinth, maze, right? And you're going to turn left and right until you find a dead end, right? Or you find the treasure. Let's try that one. You go into the maze. You can go right or left. Which way do you go? Right, okay? Whenever I make a decision, I've got that diamond shape, this diamond shape right here. Right or left? True or false? If right, it's true. If not right, it's false. If my decision is to go right, it's true, right? The condition is true. So depending on where I go, so I go right, okay? Now I can go right or left again. Do I want to go right into the maze or left? I go left. Okay, now I go right or left again, right or left. And I keep going into the maze to form what we call a decision matrix, right? The decision matrix, and I'm going to use another tool for this, a little better than this, easier for me anyway. I'm going to go into Fireworks, which I'm very familiar with. I'm going to clock out of this one for a second. So bear with me. So here I am in Fireworks. I'm going to make a canvas that's about a 1024 by 768. Kind of a big canvas, right? It's all transparent. But I'm going to make the canvas color white for now. And here I am, and inside Fireworks, I start off at the top. Here's my top box. I don't like the yellow color, so I'm going to change that yellow color to black. Okay, so here's my yellow color for my box, right? And inside my box for this drawing program, I'm going to start typing inside here, and I'm going to go into the maze. Right? That's an interesting font. I don't know where I got it from, but that's fine. Here's into the maze. My box is not big enough. I'm just going to expand it, make it a little bigger. There we go. And I'm change size. So I'm into the maze. Here I am, right? And then from there, I want to, kind of go from here into the maze. I can turn right or left, right? And again, I can choose any shape I want. Let's choose this rectangle, right? Actually, it'll be a square, right? There we go. There's a square. And what I want to do, right, is I want to rotate this thing so to make it look like a diamond shape. So there's my diamond shape, right or left. Okay, now I can go, which way do I want to go, right? So I want to go right or left. This is a series of decisions that I'm going to make, right or left, right? Right, depending on which way I want to go. When I go right or left, right? If I go this way, I can also go straight. That's a decision too, right? How about right, left, or straight? I can do that as well, because I can program the computer to tell me which way I want to go. Right? That's a decision as well. Right, left, or straight. So depending on which way I go, right, left, or straight. By the way, it would use a different kind of a different symbol, not this one. But let's say I wanted to make this right or left thing work. I would split one way or the other, right? And then from there, I would draw another one of these rectangles, or sorry, I keep saying rectangle. Another one of these diamond shapes over here, where I have another decision to make, right? Furthering my left to right kind of mode of transportation, right? And I keep going down. The symbols I'm using are just ways to describe my decision matrix, right? Of course, I killed my PowerPoint presentation too, I think. That's what I killed. I didn't kill my my thing. I killed my PowerPoint presentation, which is totally fine. Bear with me while I get it again. And I'm having technical difficulties. That's okay. Let's go back into making decisions. We didn't go far. So we talked about the flowchart structure, which is important to understand because what we're doing here is we're following a set of instructions. Right? So remember, whenever we use an if statement, we're comparing it with a single decision. If whatever the condition is true, then do whatever in my code block. If it's not true, skip this code block. I'm not going to do this. It's almost conditional code. So if the condition I name is not true, skip over this bunch of lines inside the code block, right? This is what it looks like. If, right, the number is less than 5, if that's true, write A. If it's false, write B. And if you notice, whatever the condition, the result of the condition is this parallelogram, right? These are the symbols that you're going to use. And this is what it looks like in real code. If my number is less than 5, oh my God, who wrote this like this? This isn't right, and I'll explain why. Console.WriteLine B. If this is true, write this, otherwise write this. We're going to talk about this in a second. Ways of writing this thing. Here's some other decisions. If the number is less than 5, if that's true, write A. If it's false, also write A. Right? Either way, you're going to write A. This is incorrect. The semicolon here is a problem. It's an error. Because this is what the semicolon does. It stops the if statement. Right? There's no code block here. That's why it's easier. If I was going to write an if statement, I'm just going to kill this stuff right now. Right? And let's say, for example, my age. Okay, I killed my last thing too. Let's say I set my age to equal to 45. That's me, right? And let's say I want to compare my age. I say if age, right, is less than 20, less than 30, let's say, then do this code block. That's the right way to write an if statement. If, whatever the condition is, now I've tested for less than, I can test for equals to, I can test for any one of those conditional statements. When I test for equals to, I got to use double equals, because if I just put a single equals in there, I'm actually assigning, and it'll give you an error. You cannot assign, right, inside of a condition. Yes?
You can also put equals to or more, right?
Yeah, greater than or equal to, like this. Greater than or equal to 30, which is, in this case, my age is true. It is greater than or equal to 30. If I say less than or equal to 30, then this condition becomes false because my age is 45. Let's test that. If my age is less than or equal to 30, I'll say the world is your oyster, right? Right? The world's your oyster. It means you can do anything, right? Your world is fully in front of you, right? However, if it's not,
Console what? You didn't finish it.
sure, that's good. Console.WriteLine. That's what I meant to do. Console.WriteLine, the world is your oyster. However, if it's not, right, I'm going to make another statement. I can combine it with an else, right? Else console.WriteLine. You're getting old, right? And of course, because we're making our program, we want to put those pieces of code in here, which is console.WriteLine. Press any key to continue or to exit. I mean,
So
then console. No, I'm going to get rid of it in a second. Good point. Console.read key, right? I don't care about any of this stuff because it makes no sense to me, right? I'm just doing this stuff. So if I'm 45, if my age is 45, I want to say, hey, let's add another console.WriteLine just to give us a little bit of separation, okay? Okay, I'm going to run it. What does it say? You're getting old, right? Because why? My age is 45, right? I'm going to go properties, colors, change my background to white, and my screen text to black. When I go to my font, pick Consolas, pick 20. You're getting old, right? Because, why did it say you're getting old? Because I said my age is 45, and my condition for it to be true is, I'm testing if this condition is true. If age is less than or equal to 30, then print this out. Well, it's not equal to 30, and so I'm going to use it's going to go to the else condition.
Well,
right?
the world can still be yours. It's still your oyster if you own it 30.
Well, Ben, I'm not just 30 though, buddy.
You still got a lot, man.
So that's why it's not my oyster. Getting old, right?
That's like a...
Right. Here's the thing you can do if you don't know what the person's age is and you want to have a number that's not fixed like this. What could I do, right? So I'm going to say I'm going to have a string value. I'm going to assign it to prompt. This is the easy way to understand it, right? And I can say, well, prompt, right, is equal to console.readline, right? I want to do that for sure. And I want to do some kind of console. See, I'm writing backwards, .write, because I forgot to put the console.write that says enter your age, right?
Are you going to teach your kid how to write this stuff?
Maybe. Okay, and here's a problem. I don't have a value for age, so I need to convert it. I need to say age is equal to convert to int32 prompt, right? I need to do that because that'll convert my prompt, whatever I get from this read line, into an integer. I'm just breaking it down into 2 lines. And by the way, this line and this line, right, is equivalent to age is equal to convert to int 32 console.readline. Do you see this? Do you understand what I'm doing? Sorry, I messed up this one. You see that? This line here is equal to these 2 lines here. Do you see that? Here I'm breaking it down to 2 lines. Prompt is a temporary variable, a string variable that I'm taking the value that I get from my console and putting it into prompt. Age is an integer, and I'm taking my prompt, converting it to integer, and putting it into age. That's one way of doing it. Or I can do it in 1 line. Age is equal to convert what I get from the console to integer, right? No prompt. There's nothing in the middle. Both solutions are correct. This solution is more efficient because I don't need this. However, I would accept this. So I'm going to put this as a comment, right? I'll say this is more efficient. Okay. Because we're not going to do it, we're going to do it this way. When I'm going to comment in here, this comment, what does it do? The compiler ignores comments, so it doesn't even see this in code. It just skips over it. Right, we use this for us. This is for our comments for internal documentation, right? Okay, I'm going to kill this. I'm just going to go with the other way around, this way. Okay, let's try this out. So enter your age. This line 18 is going to get a prompt from the console. Line 19 is going to assign a converted number from the console into my age, which is going to be an integer. Line 21, I'm going to use my if statement to check to see if my age is less than or equal to 30. If it's true, it's going to do the first statement. Else, it's going to do the next statement. Okay, that's what it's going to do. Huh? Just 1 second. Here, let's try this out. Here's my age. I'm going to put this 30. Hey, the world is your oyster. Okay? If I go run it again, right? And my age, right, is 31, less than or equal to 30.
You just turned 31.
You're getting old, right? Conditional statements.
Your birthday?
Right? Does that make sense to you? Right? What if, here's the question. I'm just going to put this in stasis. I'm going to put this in stasis. Which means I'm going to take this whole section of code and I'm going to comment it out, right? So I put all this code in comments, right? What is that? What happens when I put my code in comments? The compiler, C# ignores it. So I've taken this else condition out, right? And now I only have this one. What will it do now? Well, let's take a look. Here's my age. It's 30. It says, the world's your oyster, right? But when I turn 31 this time, actually there's a movie, right? There's an old movie called Logan's Run, right? And when everyone turned 31, they were shot, right? Okay, anyways, let me go to this actual movie, right? Look, it doesn't do anything. I'm 31, I don't get any message. Why? Because I don't have an else condition. I've got an if condition, and if this condition is not met, it skips this code block completely. And then there's nothing else except for this press any key to exit, because it ignores my comments. Yeah. You can do as many as you want. If, else, if, else, if, else, if, else, if. This is if and else. But you can also do else if. Let's try this. Okay, and then I'll break. Okay? So I want you to get this piece.
Can you do if, else, else, else?
No, not else, else, else. Only one else. In your chain of if and else's, you can only do one else, but as many if, else ifs as you want. One if, bunch of else ifs, and one else. Here's how it looks. If age, not really, if age is less than 10, right, we're going to say you're too young, right? Else if, we're going to say this, right? Else if, right, we're going to make another condition. Age is less than or equal to 30, the world's your oyster, right? And then finally, else, whatever, anything else, you know, you're too old, getting old, right? But this makes an assumption. This is kind of weird, this little assumption. Let me check this out and explain what's going to happen. Let me just check this out, and I'll make this thing look like it should in 1 second. Here's my console to write line. Let's take this one. This is the right message, right? And this one, I don't know why I did that. That's awesome. Hold on a second. That was weird, man. It's almost made a link. That's what it made. There we go. And you're too young. So if you're less than 10, right? You're too young, right? I want you to see what this happens. Or you're so young. I will say, well, so young. Tell me what's going to happen with this code. Let's go through it.
It's going to give you a spelling error.
Where? What, for this?
No.
Yeah?
Where you are.
Oh, you are. I won't give me no spelling error.
I'm kidding.
You're so young, right? But tell me what's going to happen. Let's go by line by line. If I enter my age and I enter a value of 40, right? Let's say my value is 40. I go to my line 21. Will I pass this condition?
No.
Is my age less than or equal to 10?
No.
True or false?
False.
False. It skips this piece. Now I go to the next piece. Is my age less than or equal to 40? Less than or equal to 30? No. Skips. Goes to my else. You're getting old. Okay? Here's another one.
Are you supposed to specify if it's like 40 or older, or just else?
I'm just saying, I've created a control structure for you. This may not be the right thing to do. We're gonna test it. But hold on. Here's the next one. Here's so I said 40. What if I'm 30? Is my age less than 10? No. So I don't get this message. Is my age less than or equal to 30? Yes, I get the world is my oyster. I don't have the else because I've already completed this condition, right? So I skip this piece. Okay, here's one. I'm 10. Is my age less than or equal to 10?
Yes.
Yes, you're so young. Go to the next piece. Else if age is less than or equal to 30. Well, I don't go there because it's either this or this or this, right? It's not all of them. Let's try this out. So my age is 10, right? You're so young, right? My age is 30. The world is your oyster, right? My age is 40, getting old. Give me another message every time, right? Works. Here's where we have a problem. What if I did this? Instead of else if, so I can do this. If. What if I did this instead? This is an issue. This is a problem. Right? What if I did this? Now I'm going to do the same thing. 10. Oh,
So it makes it the same line for everything.
do you know why? Because if I'm 10,
Then you're all of them.
I'm less than or equal to 10, I'm less than or equal to 30, and I'm less than or equal to 40. If I make this greater than or equal to 40, and I run it again, and I put 10, well, I'm so young, and the world is my oyster, which is probably true, right? So both of these conditions are met. This one is not, right? How about if I do it again, and I say, I'm 30. Well, you know what? The world is your oyster, but I'm not young, right? So this is, it's okay to do this as well. A bunch of if statements, and not if else. If else else, if else if else, only one of those conditions is going to be true. Not all of them can ever be true, right? However, well, most cases. But if I go a bunch of if statements, all of them can or may not be true. Depends on how you code it. So I'll leave you with that thought while we take a short break.